Mok AP Problem 5. We are given the chemical equation 8H plus 4Cl plus 1 MnO4 turns into 2Cl2 plus 1 Mn plus 4 H2O. For part A, subsection 1, we're asked to calculate the number of moles of Cl present before any reaction occurs. We're given 25 milliliters and 0.250 molarity of NaCl. So what we have to do is we have to multiply the liters and the molarity, and since we don't have the liters, we'll just convert it. So we convert 25 milliliters to liters. That'll give us 0.025 liters, and we multiply that times 0.25 molarity, and that'll give us 6.25 times 10 to the negative third moles of Cl. For subsection 2, we're asked to calculate the volume in liters of the chlorine gas that is sealed in the container. And we just use the multimole ratio to find the chlorine gas. So 6.25 times 10 to the negative 3 moles of Cl, and then divided by 4, and then multiply times 2, and that gives us 3.125 times 10 to the negative 3. Then we use the ideal gas law, PV equals nRT, as seen here. And that'll show us V equals 0.0797 liters of chlorine gas. For part B, subsection 1, we're asked to find the order of the reaction with respect to each of the following, using the information from the table. From the information on the table, we have 3 trials for Cl, MnO4, and H+. And we're also given the rate of disappearance for the MnO4. So for part subsection 1, we're asked to find it for chlorine, and for that we did reaction 2 over reaction 1. And for reaction 2, it's the rate of disappearance is 2.03 times 10 to the negative 7 over 2.25 times 10 to the negative 8. That'll equal the K's, and then 0.0104 over 0.0392 N, and then 0.0400 for both. So we just cross off 0.044 or 0.0400, which is MnO4, and the constant K, and we're given, once we divide all of them, we're given 9 equals 3 to the power of N, and then we can divide to find that N equals 2, and the order of the reaction is 2 for chlorine. For subsection 2, we need to find the order of MnO4. So for that, we just use reaction 2 over reaction 3, and as before, it's 2.03 times 10 to the negative 7 over 1.02 times 10 to the negative 7. That's the rate of disappearance, which will equal K, molarity 0.0312 over 0.0312, and then for MnO4, it's 0.004 over 0.002 M. And as you can see here, when we divide it all out, we get 2M equals 2, and that means that M is equal to 1, which will mean that the order of reaction is 1 for MnO4. For part C, subsection 1, we're asked to find the rate law for the reaction, and in part C, we're given that H plus is third order. So I'm going to use reaction 1. So the rate would equal K Cl2 MnO4 1 H3. Now for part 2, we're asked to calculate the values of the rate constant K. For that, we'll just plug in all of the givens that are given to us in the table. And then once we multiply it, we divide the rate of disappearance by all of the molalities, and then that'll give us K equals 1.93 times 10 to the negative third. For the last part, D, it asks if it's likely for the reaction to occur in a single elementary step. And the answer is no. It's not likely to happen because of the fact that the orders do not match the coefficients in the compounds in the balanced equations. See, 8, there's 8H, and which doesn't match 3, so it doesn't work. 4, which doesn't match 2, so that doesn't work. But we do have one MnO4 and also one MnO4 here. So that works, but for the entire thing to work, we need all of them to work, and that doesn't happen.